Hello and welcome. Got one more special edition case test video for you. So I'm testing the finals case for the Microsoft Excel World Championships. This is an exciting one. It is based on the game of chess, except it's chess on an exceptionally gigantic, enormous board, 100 by 100 squares, lots and lots of pieces. So yeah, I've taken a minute to read through it. I'm going to walk you quickly through the questions and then we'll dive on in. The bonus questions, I'll just talk about those when I'm answering them. So first, just count how many of each type of piece are on the board, count the point value of different pieces on the board, and you're given the point value for each type of piece up here. So that's just pretty straightforward stuff. Total point value of the pieces located on the following rows or columns. Again, pretty straightforward. The rows and columns are they're numbered down the rows and letters across the columns, just like Excel does it. Then what is the total point value of the threatened opponent pieces in each game? And there's a quick guide over here. So it shows you the king can threaten the sort of squares immediately around it. One to the left, one to the right, one up, one down. So there's 9 squares, including where it lands itself, and I think it specifies somewhere. Specifies in one of the levels that you can place a piece on top of another piece and it captures that piece. It doesn't mention in this level, so maybe none of these is. Let's just do a quick check. Little sense check. Say indirect board and that. And let's see. Yeah, they're all empty. So that makes sense. So they didn't specify it there. I'm just going to put a note here. Maybe specify. These are all empty. I'll make that yellow so I remember that later. Okay. So anyway, that's level 4. Then level 5, you've got a pawn, which starts off somewhere. So like in this example, it starts off in CN99, which is somewhere over here. And it basically moves its way up the grid. And there's some decision rules. So if there's a piece so pawns move forward one space at a time, but they attack either to the left or to the right. And so the idea is if there's a piece you can attack, first preference is to attack a king. Second preference is to attack a piece that gives more points. So, the standard chess rules is each of these pieces have a certain point value. The king is, if you catch it, you win the whole game. So there's no point value associated with that. So first preference is king, then queen, rook, either knight or bishop, and then pawn. Knight and bishop are both worth 3. And then if both opponent pieces have the same point value, then attack the one on the left. And you ignore blocking pieces. So in other words, in this case, we start off in CN99. Let's see. So you capture that, you capture that, you capture that, you capture that, capture that. At some point, there's supposed to be something blocking. Okay, sorry. So it says, yeah, the one placed in S99. So if we come over here, if there's one in S99, then there's a piece in the way of it and a piece in the way of that. And it says basically, as long as there's not a piece to capture, you just keep moving forward. Imagine that you can just move through these ones like a ghost. So you don't get points for capturing them, but you can also just go right past them. And that's it. You just need to figure out the total point value that they collect on the way. They go all the way up to the top of the board. And it specifies, in case you're familiar with chess, where pawns getting to the other end of the board get promoted. Don't think about that. Just what do they capture on the way? And then the last thing, we've got these laser-armed queens, rooks, and bishops. So, standard thing is that a queen can capture, well, a queen's easier to come last. Castle or a rook can capture anywhere on the line vertically or horizontally. It usually gets blocked, but in this case, it has a laser-mounted cannon or something, so it can just shoot through everything. So if you place a rook here, it captures all opponent pieces on that row, all opponent pieces on that column. Bishop, same thing, except it's all on the 2 diagonals off it, and the queen is kind of the union of those two. So anything on the diagonal and anything vertically or horizontally. And that's it. And then we get to, there's a couple of bonus questions with kind of straightforward answers, and then there's an optimization question where you have to try and figure out the best way to place pieces to capture as much of the board as you can. That one's going to be a fun one to play around with if I have any time left by the time I get there. Okay, so let's, anything else to say? No, let's get started. See what I can do in 30 minutes. I'm going to start with the bonus questions again. Why not? So let me just start by giving some things some names because that's going to be helpful. So I'm going to come up to the top of here. I'm going to name this board. I'm going to go select the board so I can get to the end of it. I'm going to name this row label. I'm going to name this column label. I'm going to name this pieces. I'm going to name this points. Okay, and then I think I'm kind of ready to go. So there's a few different ways I could think of doing this, but I'm going to try a slightly fancy one. I'm going to say make array. I'm going to make an array that returns the location if the pawn can capture 2 queens from that location. Rows 100, columns 100, and the function is lambda rc, so take a row and a column, and we're going to say if, well, first we'll say if the row is, if it's in row 1, then it can't capture anything, so if r equals 1, then nothing, otherwise if, actually, sorry, so if it's in row 1 or if it's in either of the extreme columns, then it won't be able to capture 2 queens. So I just want to deal with those 2 cases right away. So if or r equals 1, comma, r equals, sorry, c equals 1, c equals 100, then give me nothing. Otherwise, if index board, and we're going to go row -1, column -1 is equal to queen. And we want queens in both positions that we can capture, so we'll do that. And this with column +1. So if that's equal to that, then I want index row lab r and index col lab c. Otherwise, nothing. Close down my ifs, that's my lambda, that's my make array, and then I just want to concat that. And hopefully, if it's all working, that will return 1 cell. It returns a few cells. Okay, that's interesting. All right, so first things first, I guess I got to do my column label before my row label, or else I'm not referencing this properly. So AU14, let's go to AU14 and see if that can indeed capture, does it need to be empty? Yes, not occupied. Okay, fine. So so I need one more test here. So I've got and that, and index board rc equals empty. No matches. Dang. Shoot. All right, well, I guess the answer is I should probably jump straight on. All right, so let's just start with some easier stuff. Countifs board that. And just confirm it works for the example. It does. So here we're going to say the same thing, but multiply by x lookup that piece in pieces returning from points. Called PTS. Fine, yeah, no point value for kings. That's a little tricky, but I'll allow it. Okay, total point value of these. So I'm going to say sum of if, sum if or row lab equals this, comma, col lab equals, col lab equals this, then x lookup board in pieces returning from points. Otherwise, 0. Sum that up, NA. Dang. Oh, yeah, fine. So So if there's no match, then it's a 0. That's not good. Why is it exactly the same? Oh, sorry. I can't put an OR on that because it'll wrap the whole thing up in an array. That's why. So it's, sorry, that plus that will give me an OR. That's 116. It matches the 134. Okay, cool. So I think that's working. Let's keep moving. Okay, each of the pieces you place on the board with me. Remember the white pawns attack covers total point value of third. Okay, fine. So I'm gonna ask for the row and the call. The row is going to be if error minus minus write this 2. Oh no. Write this 3. Then if error. I'm sure there's a smarter way to generalize this, but I'm just going to say try taking the last 3 places. If that doesn't work, try taking the last 2 places. Otherwise, take the last 1 place, and whichever one of those is a number will work out. So 71, 43, 89, 29. Okay, perfect. And then the call is just going to be left this, len of this, minus len of this. And then I want to call number, and that's going to be x match this against call labels. Okay, so king then. We want the total point value. Okay, so you know, I'm just going to make a version of the board that has point values. I'm sure I'll keep using it. So if a1 equals blank, then 0, otherwise x lookup a1 in pieces, returning from points. Lots of NAs here. Why? Why all the NAs? It's not some other. Yes, it's a space. Okay, fine. I guess that lets you navigate the board more easily. Ah, wait. That's what's going wrong with this thing up here. Okay. Put a space there. Aha. That's better. And is that indeed, where are we? There it is. That is indeed a pawn place that can attack 2 queens. Nice. Okay. Okay. Now I'm kind of tempted to try and do bonus 2, but heck, I'm down here. Let's keep moving. Okay, so kings, first of all. I'm going to put sequence, comma, 100. I'm going to name this call lab num. So now I'm going to say some ifs. All right, I didn't name board value. So I'll call this board points. Now I'm going to say some ifs, board points where call lab num is less than or equal to, and column number minus +1, less than or equal to that +1. So in other words, basically I'm saying if it's if the column number is between that -1 and that +1, and if the row number is between that -1 and that +1, that's going to be my sum if condition. So it's going to be row lab has to be, again, less than or equal to the row number, which is, move it out of the way, which is j, 124. So less than or equal to that +1, greater than or equal to that -1. Didn't like that. Really? Yeah, okay, fine. Fine. So the issue is that some ifs, dynamic arrays will generally, if you give it, you know, one what am I saying, one vector and one array, it'll scale up the vector. It's called broadcasting to make it fill the array, but some ifs will not do that. So I need to change this to a sum of an if, which is fine. So if, then I just need to multiply all these together. Column label number less than or equal to that plus 1 times column label number greater than or equal to that minus 1 times row label number less than or equal to that plus 1 times row label number. Oh, sorry, I've left the quotes in. Should not have left the quotes in. Greater than or equal to that minus 1. Then give me board points, otherwise 0. And that does give me 11. Good. Unfortunately, that's a totally different formula from all the rest of them, but it's easily enough fixed. So then, I'm going to do it a slightly different way for the knights. For the knights, what I want to know is, so let me just quickly explain what I'm going to do with the knights. So all the pieces that a knight can take are 1 square away in one direction, 2 squares away in the other direction. So what I'm going to do is just look at the square of the distance by the Pythagorean theorem. So in other words, if the distance from the given row and column, if the square of the column difference plus the square of the row difference is equal to 5, that means that it is a knight's move away. So that's my kind of sneaky knight-specific formula I'm going to use here. So here's what we're going to say. We're going to say col lab num minus that squared plus row lab num minus that squared. All that is equal to 5, then board points, otherwise 0. And just let me double check one of them. CE95, I think you can take 29 points according to that. CE95, where are we? Yeah, so that points to way down here. I just use the trace dependence to find the cell that it points to down here. And then, so the points that I can take are that, this, and 2 zeros, and that does add up to 29. I can see that down the bottom. Okay, so turn off trace dependence arrows, feel good about my knight formula, and finally the pawns, that's more straightforward. Let's just double check if any of the, yeah, some of these are at the edge of the board to try to trip me up. Fine, so I'm just going to say index, board points, row, need to subtract 1 from the row, subtract 1 from the column, plus index, board points, subtract 1 from the row and add 1 to the column. But then I need to say if, so I'm subtracting 1, so if this equals 1, then 0, otherwise that. And I need to say here if this equals 100, then 0, otherwise that. Feels very weird to do a level like this with 3 completely different formulas, but I don't know a better way, so I'm going to keep moving. All right, so this one I'm definitely going to have to data table this, although I am looking forward to seeing Bo tackle this in a completely non-data tabled way. But for now, let's do this. So I'll put my picker. Let me see, do I have space? Yeah, I have lots of space here. So my picker, I'll use my input format. It's going to be example 5. And then it's going to be equals x lookup that on here, turning from here. Okay, so it's a row call. So the row is that, yes, the call is this. And it always starts in 99. Cool, that makes sense. Okay, so TRG1, TRG2. Yeah, I'm gonna need the actual, no, I just need the points. Yeah, let's let's get the target. Okay, so target 1 is going to be the one to the left. So if column equals 1, then a space, otherwise index board the row -1, the column -1. And then same basic idea here, but now it's if it's equal to 100, then blank, otherwise do that +1. Okay, and then T1 val, T2 val. So I'm going to say if this equals king, and I'll just call it 1000. Otherwise, XLOOKUP U172 in pieces, returning from points, and the error is 0. Okay, so I've got 2 pawns I can take. So then I'm going to say offset. So this is going to be how many columns am I going to offset by. So I'm going to say if, sorry, let's just do max of these 2. If this is equal to 0, then my offset is going to be 0. Otherwise, if this one is greater than this one, no, do the other way around. Let's say if this one is greater than this one, then I'm going to the right, in which case it's +1. Otherwise, it's -1. And you'll note, because I'm saying greater than here, the -1 is picking up the equal case, which means tiebreak moves to the left, which is exactly what we want it to do. So then, now I just need my next thing. So this is just going to be, we always move forward by 1 row, and it's going to be this plus that offset. And everything else, I think, just copies down. So let's see, there's a piece on the left and we take it, there's a piece on the left and we take it, there's a piece on both sides, but the one on the left is more valuable, so we take it. There's a piece on both sides, but the one on the right is more valuable. Okay, good. That's all looking kind of sensible. I'm going to go until we get to row 1. A few more. Overshot. Okay, and I don't actually want to take it to row 1 either. Because, yeah, that's right. So now my point value should just be, I've used 1000 to distinguish the king, but obviously I'm asking for point value, so I'm going to ignore the king. So let's say less than 100. 179, that matches good. Happy days. So then I'm going to put that here. And then I'm going to do sequence. Actually, I can just do this. Make myself some space. Alt-T, column input cell is this. Calculate. It's cool. Okay, and then this one feels like it should be relatively straightforward. The only thing I need to worry about is, am I multiply taking the centerpiece? So, sorry, actually should have taken this as well. All right, so what I'm going to do is I'll do castles first, because that's very easy and similar to something I've already done before. Then I'll do bishops, and then queens will be the union of castles and bishops. So, castles, I'm going to say equals sum if the row label is equal to this, or, which I'll do by plus, not by or, because that'll mash them all together into one, plus col label is equal to this, oops, this, then board points, otherwise 0. That sums up to that, and then I just want to subtract off minus index board points. So basically I'm, no, actually, sorry, I don't need to subtract off anything. So here I'm saying I have one combined if that's saying here's the check it's in the row, here's the check it's in the column. But if those are both true, in other words, if you're at the intersection, then it'll still only count it once. So I was thinking I needed to subtract off, but I don't think I need to subtract off. So that's that. Bishop's a little more complicated. So how are we going to do this? We're going to say if, so the logic that I'm going to use for the bishop is basically sorry, whoops, come back over here. If you think about it, the column difference and the row difference have to be the same absolute value. So in other words, it's either 3 and minus 3, or it's 3 and 3, or it's minus 3 and minus 3 or something. But the absolute value always has to be the same amount. The number of rows and columns that you've gone away from where the bishop is has to be the same. And if that's the case, then we're golden. Someone is messaging me. It can wait. All right. Okay. So we're going to say, sorry, I already had one copied down. So here, I'm going to say if the absolute value of the row label minus that row label is equal to the absolute value of sorry, that sorry, that is not necessary, of that minus that, then board points are always 0. No, it didn't work. What's going on here? Okay. Oh, sorry. Call lab no. Still an error. Oh, sorry. Yes. Then I need to also point to the number here. Okay. So now I have something that I think is working there, and then the queens, like I said, are just going to be the intersection of those two. So let me just grab this. So I want same row or same column or same diagonal. So it's going to be those two absolutes are equal, plus for an or, and then instead of 219, it's going to be what it says, 231. And let's just check. Does that match in the example 374? It does. Hooray. Okay. Okay, so now, how can I do this knights thing? I don't know if I can. Same opponent's piece can be captured only once. If you place your piece on a cell that is occupied, the opponent's piece is considered captured. Okay. So, let's see. I'm going to move this over here so I have a little more space, and then I'll copy it and put it up here. Have I moved it far enough? Yes, I have. So that is, nope, sorry. That now is, so let's just say I put the queen in A1 for a second. Whoa! Oh, what? What is the data validation rule? Whole number between 1 and 100. What? That's the wrong data validation rule. So I'm just going to clear that. Let's say OK. Clear them all. Clear all. OK. So say I put the queen in A1. Captures 377. Yes. OK. So what I want to do, I think, is, I don't know how much calc time I have to run this. I guess I might just try and take the highest value row, highest value column. So sum of this, and the max of that is 160. That occurs where exactly? So look up, don't even need to look up because they're numbers, so let's just X match. Sorry, what did I say it was? I think I said 160. 13. That's the max there. And then same idea here. Some here's what I'm going to do. I'm going to sort them. Sort this to minus 1. So this is the order in which, obviously these things will interact with each other, but that's the order in which I would want to attack those, and then sort by sort transpose. That by the fourth column minus 1. So this is the order in which I would like to tackle those. Okay, so let's say I put the queen on CM13. Reasonable. Okay, next, castles. Let's put them on the next two most valuable, so 81, 61. Let's go AU 81, AI 61. AU 81, AI 61. And the knights, tricky, don't know. So then row differences, which is what will identify the bishops. Sequence of 199, I think, starting from minus 99. That'll go 2 plus 99, yes, and I want to sum if row lab minus, am I doing this right? I don't even know if I am. Minus call lab num equals that, then board points, otherwise 0. That should, in theory, tell me my most valuable diagonals. Am I doing that right? Oh, yeah, hang on. I need to do that. That's negative diagonals. Then I need to do the same thing for the positive diagonals. And again, that's 199 options starting from 2. And basically the same thing here. Except now we're going to say plus. Now, I don't know how quickly I'm going to be able to convert this back into something actionable, but whatever. Do the best I can. So sort this, comma minus 1. Alright, no, comma, second column, then minus 1 descending. And then same thing here. So what does this even mean? So this is the row difference, this is the row and column difference, that's the sum. So that divided by 2 is going to give me 1, and then no, shoot, sorry, pointing at the wrong one. This and this is going to give me 1. No, that's not right. Oh, shoot. Oh, that's because they don't intersect. Damn. Okay, so I need to sort on the whites separately. I'm running out of time here. All right, 0. I mean, middle of the board seems like a sensible place to put 2 bishops, so let's just go 50 is AX. Let's go AW and AX 50. AW 50, AX 50, and then king, no idea. Put him somewhere in the middle. Yeah, I definitely don't have time to do this very smartly. Let's go AB 35, totally at random. Let's put this one in C, A 12, this one in M 89, and then each of these can be what the heck ever, equals index call lab ran between. We don't want it in row 1, so 2, 99, and ran between 2, 100. Well, there's my answer. Could be totally bogus. But do I have time to do the knights in 30 seconds? No, I definitely don't. All right, well, that's what I made it through. So hopefully got all of this right. I'll check that in a second. And got the first bonus, and I got something vaguely credible on the second bonus. That's all I had time for. Okay. One cell on the board not occupied. I'll come back to that one, but let's see if I got the answers right. So just copy this, put it here. I'm going to say equals if this equals answers, same cell, which is what E62, then give me D62, otherwise 0. So those are right, good. I'd be alarmed if they weren't. Those are right, good. Those are good. Happy days. That one is good. That's good. And this one is good. Hooray. All right, well, that's all I got time for today. Thanks for watching. See you next time.